could cater for if people haven't paid for a meal and would like one. So it's a very good chicken pie, obviously. So do take advantage of that if you'd like to. And let me introduce our speaker, Gareth Roberts, Emeritus Professor of Maths Education at Bangor, and writes books basically looking at Wales as a place of not just song but maths and science, and many great Welsh mathematicians celebrated in this book. I've just bought my copy. It cost pi times 3.18, very good value. I did buy the English one. There is a Welsh copy. Originally in Welsh, did you? Right,
Yeah.
First in Welsh?
Yeah.
And so there's plenty here at the end if you would like to buy that. Can I just also say, if anyone's here who hasn't come before, can they put their hand up if there's someone new? Because we can get your email and then we can keep you on the list if you'd like. So you know already what's going on. So that's fine. The ratio of a circle's... I'm going to get this wrong, so tell me where I go wrong.
Go on then.
The ratio of a circle's circumference to its diameter is a mathematical constant, and it's an important one, and Archimedes knew about it, approximately. But Professor Roberts knows exactly, as I hope more of us do, 3.14, and I would say 2, but it should be 3.141, and then that goes on forever. And 2,000 years later, this gentleman, oh no, where's he gone? Where's William Jones? There we are. William Jones gave it the name pi, and he's from Anglesey, and self-taught mathematician. So we're going to hear about William Jones, and then I should just say at the end we've got we have to come up with to keep our status as whatever we are. We have to give a report. So we're going to give a report at the end of the talk. So thank you very much for coming, and William Jones.
Now, do I stand up?
Whatever you like. Do you think? I think sitting down is okay. Is it? Yeah, it's fine. Shall I remove the plant? Would that help?
We're all sitting down.
Well, you're okay. You're okay. Yeah.
I think the plant's an obstacle. There we are. How's that?
Surprisingly, this is the first time I've ever been to Rhosneidr. Apart from I went to a school in Rhosneidr when I was working as a maths what's the term? Very prophetic. I worked for Gwynedd County Council when Gwynedd was Anglesey and the rest of Gwynedd. And it was a joy to have the privilege of going around schools. Because you learn more. I learned far more from from pupils and teachers in schools than they ever learned from me. Because I tended to find that teachers were really being very inventive in their teaching, and could do some amazing things with kids. Apart from when they did maths, because then there was, I came across an example very recently of someone who said, "Oh yeah, when I was teaching maths, I said to the kids, well, let's say all over between 9 and 10:30, and then we can all enjoy ourselves." As if maths was some kind of threat, and possibly if you go back and think about your own experience of being in a pupil in a maths class, primary or secondary, I guess that you've all got your own stories. I got some horrendous stories. I really have got some horrendous stories about maths in general, and I'm not sure if I should share them. But if I show one of the most horrendous examples I came across as a maths advisor was I was down in a school in the Cardiff area, and I'd been invited to the school to talk with the teachers and with the pupils about maths, and we did some games and stuff, the kind of stuff that you do. And then when it came to the time for a cup of coffee, all the staff came into the staff room, and we chatted about what we'd just been doing. All except one person, and that one person sat in the corner. She was a lady. She sat in the corner. Hello. And she clearly was uncomfortable. Yeah. And at the end of the break, I went to have a chat with her, and she was very uncomfortable. And she'd gone very red in the face, and she sweated. Yeah. Well, and I asked her, well, and it turned out that she wasn't a teacher. She was a teacher. What's the phrase of somebody an assistant teacher in the school, and she'd been there for a number of years. And then she said to me, "Well, I've always been afraid of maths." And I said, "Well, okay. Why is that?" And she told me a story that she'd been in the school not very far from here as a pupil. And she wasn't, she didn't shine in maths, but she was okay, But she had the experience of a teacher who was actually, in a sense, using the authority of the subject to turn that round and to use that authority in a negative way. Maths, 2 + 2 isn't 5, is it? It's wrong. You put a cross rather than a tick. There are no options, are there? You're either wrong or you're right. And some teachers use the authority of the subject as the authority in the classroom to keep the kids quiet, type of thing. And this girl had a difficult time with maths, and the teacher wasn't very helpful. And on one occasion, she had all her sums wrong. Every one of them was wrong. And what the teacher did was to give her lines. Now, do you remember doing lines? Yeah? 100 lines. And what the lines were, this is in Welsh, translated is roughly like, I'm sorry that I am so stupid. Can you imagine this? 100 lines to say that? And then she said that I went home and I told my parents that I had to do 100 lines. And they asked, what are the lines? I'm sorry, I'm so stupid. And the parents said, well, the teacher knows best. That would not happen today, would it? That would not happen. And when I asked her if something happened like that happened for her child, what would she have done then? Oh, I'd gone to the school immediately, And it's just that use of mathematics in a negative way. It's either right or it's wrong. If it's all wrong, you get punished, for heaven's sake. So after having been had a career in the teaching of maths and helping pupils, helping teachers to be to look for opportunities of enjoying their maths, I retired. Just a year or so ago. And I then began to do things like writing books and trying to popularize maths. And as you've shown, of the books that I have compiled, the first, that came out 2 years ago, covering Cewri, literally counting our giants. And the point that you were making was we have in Wales people who have achieved high status in mathematics, but are not well known. We are well known as being the land of song. We're not well known for being the land of physics or chemistry, or mathematics. But that can easily, but that's a false position. do to many. Should you have 100 lines? I should not be late for class. And essentially what I've done here is a book about mathematicians from Wales over the centuries. And it turns out that not many people know about them. But it turned out that when I did I did a degree in maths, I did a higher degree in maths, and I got to know a lot of names, Cauchy, de Moivre, all kinds of names. But nobody ever told me who these people were. You know, you just learned oh, this is Cauchy's theorem. But nobody ever mentioned, well, what kind of guy Cauchy was. You know, and it seems to me that for any society to enfold maths within their psyche, they have to know something about the mathematicians of their area. And every country all over the world has got some people who have excelled in mathematics. But it's only some countries, England is one, where there are many mathematicians who don't need to do that, as it were. But increasingly, the history of mathematics is becoming more and more important, because it's through knowing the history that you begin to identify your culture with areas like mathematics or science. And so that's my message, really. So in here there are 12 chapters and there's one person per chapter. And it's not, in a sense, it is a book about maths, but it's more a book about the people who've done the maths. So you don't have to be a mathematician to read the book. Perhaps you do need to know that 2 and 2 is 4, but that's about it. But what you also see are the character and the people, and their involvement with maths, and how that has affected society in one way or another. So that's my Welsh version, and then 18 months later, I then adapted it into English. For the record, when it first came out, somebody came to me and said, "I'm very sorry, but I think you've spelt record wrong. There's no E at the end of record." And he's right, isn't he? There's no E at the end of record. But it doesn't actually say that. It says for the record, not for the record. And Robert Record was is the subject of the first chapter in the book. And for the record refers to Robert Record, who lived in Tenby in South Wales during Tudor times. And Robert Record is known for many things, but in particular he's known for the symbol. And does anybody know? Does anybody know what symbol Robert Record, a Welsh mathematician from Tenby in 1557, said, "I shall use this symbol"?
Plus.
Infinity.
Infinity, no. But you said plus. Yeah, he actually did use plus. Plus was invented in Europe, and he dragged it from Europe into Britain. But it wasn't that. It was the equal sign. Brilliant. Robert Record invented the equal sign. Can you imagine? There wasn't an equal sign until 1557. People didn't write it down as an equal sign. You know, people wrote it in words and said "is equal to" in words every time. Much misused, yeah. But once you get a symbol, a small symbol, and if you imagine that you're an equal sign with two parallel lines, he chose 2 parallel lines because no 2 things can be more equal because no two things can.
Equivalent.
Oh, sure.
Equivalent. More important.
Oh, there we are. There we are. But that's how he expressed it. Yeah, that no two things can be more equal than two parallel lines. But if you look at his book, written in 1557, he died in 1558. He'd written a lot of books on maths, and when he wrote that equation, that symbol, it doesn't look like the symbol that you would write down. It says two lines, but they're very long, very long new lines. You know, take up the whole page almost. And then gradually over the years, that became shorter and shorter. So now you write it, don't you? Everybody writes the equal sign, knows what the equal sign is.
Is that
But
where the expression more equal than others or something?
it might be, right? But that's the larger than sign, isn't it? Yeah. So you have the power there is in the symbol. You know, once you have a symbol for something, then you begin to do things with it. And so the maths that Robert Ricord developed was not just a symbol. He was the person. He was the very first person to write books in mathematics in English. There were no books on mathematics in English before he started writing them in about 1540. There were books on mathematics, but they were in Latin or they were in Greek. Very few people in Tenby spoke Latin or Greek. And it was his intention, and it was his, and he achieved it, to present mathematics for what he called the unlearned sort. The unlearned sort. There's those people who hadn't been to Oxford or Cambridge, essentially. You know, and he built up this vast amount of mathematics in number and in shape and in algebra. He developed algebra, and interestingly, he would, because he had friends, as it were, over in Germany mainly. Latin was the language in which they wrote to each other, and it was Europe then really was a hive of activity in terms of developing new ideas, and Latin spoke to Latin. But then when you were in the UK, you needed something which everybody could understand, and he was the first to develop mathematics in English. That's the end of my little party about that. But should you wish to buy a copy, and Christmas is coming, I've already sold 2 copies just before I sat down. They're £11.99 each. Clearly, I'm not asked anybody for £11.99.
How much on Amazon?
How much on that? That's a very good question. It depends what day it is, I think. But £10 a go. If anybody wants a copy, I do have copies, and if you want to buy one at the end, that'll be fine. As I say, it's not a book for mathematicians. It's a book for people who are interested really in things, and interested in this case in how mathematics has been influenced by people from Wales, and if you go to Scotland, you'd have a different book, how mathematics influenced people from Scotland. So it's not an insular thing, it's a national thing, and an international thing as well. Okay, I hadn't meant to say all that. William Jones, yes. So the character that I want to talk about just a little bit is William Jones, and you see he's born in 1675 to 1749. He lived. He was born in the parish of Llanvi Hanel Tre'r Beirdd, which is a parish just outside Llandefni, and he lived there they had a small cottage, essentially, just outside Llandefni. He lived there with his parents. And then his parents moved with him to Llanbabor, which is to the north of us, isn't it, Llanbabor? And they had a slightly larger small holding. And from there, William Jones could go to school. He walked to school to Llanfechell. Actually, I think a good quiz program question would be how many places in the UK or in Wales start with a double L and finish with a double L? Llanfechell. Not easy, is it? Not easy. Llanfechell. And I don't think there's anywhere else, anywhere in the world, which starts with a double L and finishes with double L. And what happened with William Jones is he went to a school. Well, it wouldn't have been a school in our sense of a school. And it's probably in the vestry of the church, something of that nature. And then one day, one of the Buckley family dropped by and spotted that this little lad was quite good in maths and was clearly understood a lot of things. And he arranged, when William Jones was fairly young, he arranged for him to go to London. And in London, he went on a ship and taught himself how navigation works. And then he would teach navigation to the sailors on the ship. He then returned eventually to London. He became friendly with other mathematicians, other math people in London, and became very friendly in particular with Isaac Newton, who was of the same period. And he helped Isaac Newton with the books that Isaac Newton wrote. Very often, the Principia, William Jones would edit them and recopy them and correct them. And he became quite a star. He became an FRS, a Fellow of the Royal Society. He became Vice Chair of the Royal Society and developed a very high profile. As part of all that, he wrote some books. The first book he wrote was about the mathematics of navigation. Having been on the sea and having seen how the sailors didn't really know what they were doing, he prepared a book and wrote a book on the principles of navigation. And then a few years later, he then wrote another book, which was a compendium of the whole mathematics of the period, essentially. Anybody who wants to know anything about maths, they would turn to William Jones's book. And it was in that book that William Jones, in the year 1706, introduced the symbol pi. So this is his number. And you might ask, well, okay, why? You've heard that pi is to do with the ratio of the circumference of a circle to the diameter. It's how many times is the circumference larger than the diameter. And as you say, it's about 3. In the Bible, it's actually 3, as it happens. There's a verse in the Bible which says, which essentially says that pi is 3. And we know it's not that. We know it's a bit bigger than 3. As you mentioned, Archimedes had worked out a way of trying to calculate it by dividing the circle into lots of triangles and fiddling about in that way. Did it in approximation. And he'd worked out that pi was something in the region of 3 1/7, a number just bigger than 3. Tell me, if you go back to your school years, I remember doing exam papers in maths for all level, and very often at the top of the page it would say, take pi to be 3 1/7, or take pi to be 3.14, I'll take pi to be 3 1/7. Does that ring a bell? That you were told what it was?
We were told 22/7.
2207, the same as 3 1/7.
Yeah, but I mean, it goes on forever, doesn't
It does, it does. But
it? Precise then.
absolutely. But it's, nobody ever told me in school that 2207 was incorrect. It was just given to us. Pi is 3 1/7, and that's it. But it is incorrect. It's only correct to 2 decimal places. Only the 1 and the 4 are correct. And if you carry on going, it's then not correct. As it happens, not every society used 2207. The Chinese, 1,500 years ago, about the year 500 AD, the Chinese used a different fraction. And I have to write it down to sort of remind myself what it is. The Chinese ratio isn't 22 divided by 7. The Chinese ratio is 355 divided by 133. And imagine now, how did they work that out? As it happens, that number is correct to 6 decimal places. Not just 2, 6. How did anybody actually work it out that was correct? And nobody knows. The history of that is gone by. But that fraction, if you got a little computer or a little calculator and you type in pi, and you type in the symbol pi, the number comes up. And very often in the electronics of the system, what the system does, it divides 355 by 133. You know, it doesn't actually keep the number pi in the system. It just divides it every time. And there you go. 3.14159 is pi to 6 decimal places. And it's as good as it, you don't need it anymore, do you? You don't need it anymore. Whatever you want to do in building something, nobody needs to have more than 6 decimal places. However, it's caught on. It's somehow over the years developed a kind of existence of its own. And people have become interested in, well, what happens after 3.14159? Well, it carries on going. And carries on going. And carries on going and never stops. So you got an infinite number, 3.14159, etc., etc., etc. In about 1989, in America, they decided that this number pi was really very interesting. It's got a symbol. William Jones has given it the symbol. But it's also a very interesting number. We should have a day to celebrate pi. A bill went before the House of Representatives in 1988 to say there shall be an International Pi Day. That International Pi Day, from that date on, was the 14th of March. Now, why did they choose the 14th of March as being the International Pi Day? There, because the 3 is the month, March, and the 14 are the first 2 digits of 3.14. So every 14th of March, that's Pi Day. That was the International Pi Day. The next development was that in 2015, by 2015, things began to develop after 1989, and because of International Pi Day, it became more popular. People would have parties on Pi Day. You sort of enjoyed yourself on Pi Day. And in 2015, the Welsh government decided, wow, this number comes from Llanfeches. It should also be recognised as the International Pi Day Cymru, International Pi Day for Wales. And as of from 2015, Pi Day has been celebrated every 14th of March, specifically in Wales. It's been celebrated all over the world, but Wales latched onto it big time, simply because William Jones was Welsh and had this genius of an idea. The main point that William Jones had discovered, not just that pi is a symbol. By the way, he chose the letter pi because pi is the Greek letter for P, isn't it? And the name perimeter in Greek begins with a P, begins with pi. So he chose that letter pi to represent our pi, as it were, because of that link with the Greek. Okay, and then the celebration of pi since then has mushroomed. And most schools in Wales on Pi Day will have all sorts of things going on. They will make cakes, for example. They will have baking. I don't know if any of you come across these examples. Has anybody come across these examples anywhere? Because they now it's now a big thing. On 14th of March every year, most schools do something to do with pie, and it could be to do with making pie because your pies tend to be circular, and then you can put things on top of the pie, pictures of pie and all sorts of things, and I might show you some of those later on.
Is that why the pie is called a pie?
No, I don't think so.
A circular pie?
I don't think so. Because pie, the food, is spelt differently, isn't it? P-I-E.
It's interesting conversation.
Yeah, it's an interesting conversation. But I don't think so. But schools are taking that on board. So schools will also have little competitions. They'll have little competitions about who can remember the most digits of pi. Now, in March 2015, on Pi Day, the Welsh Government organised that the pupils from Llanfeches School should go down to Llanfair PG, to the station in Llanfair PG, and Llanfair PG was renamed for one day as being Llanfair Pi G. And they had little competitions on the platform, and they looked for circular things and did things with circular things on the platform. I've actually lost my place now. Where was I at? Oh yes. And when I asked them, does anybody here know the digits of pi? Some of them had learned 20 digits. They recite 20 digits. And I was in a school recently and asked the question, is anybody here able to recite the digits of pi? And little girl, hand up, said, I know 55 digits. And I said, gosh, can you tell us that? And yes, she rattled them all off. I didn't know whether they were right or not. I had no idea. But this became and still is a major thing throughout the world. So there are competitions on how many digits you can remember about the number pi. The reason why I say this is that William Jones had recognised that the number was an important number and recognised that it went on forever. Nobody had proved it went on forever. But and the way he said it, he said, nobody can write pi exactly in numbers. you can't write pi in numbers. It's not 2207. It's not 3350133. It's not a number with 1,000 digits. It just goes on and on and on. It never repeats itself. You can have a number like 0.333 with all the threes, going all the three being repeated. Or you have 1 3 1 3 1 3 all the way being repeated. Pi never repeats itself. And these competitions have developed. The current record, rather than record, the current record is, how many do you think would be a reasonable world record for remembering digits? And you'd be there, sitting on the table, there'd be people there from the Guinness Book of Records, making sure that you were right, but making sure you weren't making any mistake. What roughly might you think would be the world record? 314. I like that. It's a bit bigger than that. I shall come to a savant. I shall come to a savant, yeah. But what do you reckon? The figure is absolutely astounding. It's 70,000.
No way.
Somewhere in the region of 70,000. And that was done in a day. They all sat down for a day. They had these people who checked them. And you ask the question, well, hold on. Why? Why does anybody want to do that? But it's like, why does anybody want to climb Everest? It's there, and the view's very good in Everest. Yeah, but it's somehow caught the imagination. That person was from India, and he had his Guinness Book of Records people checking these rights. Somebody else from Japan claims to have done over 100,000 digits, but there was nobody there from the Guinness Book of Records. So we assume that can't be the case. But it is remarkable. Why should you do that? I have a. Are you okay?
The slides, because the battery's gone.
Am I okay to carry on? Or?
Yeah, go for it. Yeah. The slides are recovering.
Slides are recovering, okay. Why are you doing that? I just get a book for my. Oops.
So we're just recharging the laptop.
Does this happen often?
So you're saying those numbers, but you're talking in base 10.
Yes.
Do you get a round number in any of the other bases?
No. No. It just doesn't matter what the base is. It's an infinite number. Yeah, it never finishes, which is pretty surprising, isn't it? It doesn't matter, which then gives it a sense of being a very special number. It doesn't matter how you count it; it just goes on and on.
That's good. Okay, we're good.
Okay.
Yeah.
No, it'll take a little while to...
It'll take a while, but we've got power.
We have power.
We're threatening to have liftoff.
So tell us a bit more about William William Jones, so he had this association with Newton when he wrote the book, which mentioned pi. How did it then take off as an idea? I mean, there must have been others who picked up on it and thought, yeah, we'll use that.
Yeah, it was picked up essentially by a chap called Euler. Euler spelt Euler, who was a German mathematician. And Euler really is one of the great mathematicians. And Euler essentially popularized the symbol. Euler also did things like, because pi is a very important number and comes from a circle. You would think that it would only be concerned with round things. So, for example, if you ask what's the volume of a cube or of a sphere, the volume of a sphere also uses the number pi. Or the area of a circle, pi r squared. Do you remember that? The area of a circle also uses the number pi. So you'd think that pi is something to do with curved things, wouldn't you? Yeah, that would be natural. However, pi occurs in all sorts of other things. Can I give you an example of that? If you imagine the following number. You start off with 1, and you add to it a quarter, 1 over 4. And then you add to it 1 over 9, a ninth. And then you add to it 1 over 16, a 16th. Now, can you see what those numbers are? 4, 9, 16 are all square numbers, aren't they? Square numbers. So 1 over 1, plus 1 over 4, plus 1 over 9, plus 1 over 16, plus 1 over 25, plus 1 over 36, plus 1 over 49. And carry on going, then eventually you'll see that your number settles down. You don't know, a number which is points, actually I've got it written down here, it's 5.1769, etc. 5.1769. And it settles down to be something like that. And it's an infinite number, because you can add more and more and smaller numbers to it. And if you do that, and you find that it settles down to a number which is roughly 5.1769. And people found that out, but nobody quite knew why was it that. And it's a bit unusual to have a sequence of that nature, which it doesn't come to something like 10 or or something like that. It turns out that if you add those numbers up together, you come to a number which is the square of the number pi divided by 6. Where does that come from? So all those numbers altogether are pi squared divided by 6. In other words, and then the more you look for pi, the more you find it. So you find pi goes through everything. It's not just circular things.
Radius is in a circle. If you use a compass
Yes.
and you go around the circle, its space is
Well,
6.
Yes. Well, yes, but why should all those things add up to pi squared over 6?
You're the mathematician.
Well, eventually they could prove that it was pi squared over 6. But it took people, it took Euler, about 50 years after William Jones, it took Euler a long time to prove that number was pi squared over 6. But it shows the pi, gets into the crevices of every bit of mathematics. You can't ignore it.
Is there any other number with as many qualities?
Yes.
There are other numbers with...
Oh yes, there's an infinite number of them.
the infinite number. The more, if I just show you another example which is mind-blowing, if I was to ask you to give me a sequence of numbers, so if each one you just think about a single digit, okay, and you tell me yours first, which is 3. Okay, now if I stop there, I can guarantee that sequence of digits that you just heard is somewhere in pi. Not just once, but an infinity of times. Any run of numbers, and this has been proved rather than it's not my conjecture. Any sequence of numbers appears somewhere. It might be in the zillionth digit. Yeah, that you find it there, but it's there, and it's there an infinite number of times. So the whole thing is mind-boggling, you know. It really is mind-boggling. And what I'd like to just to sort of refer to now is you refer to the savants. Now there was no European record for pi, but this chap called Daniel Tammet, who wrote a book, Thinking in Numbers, is a savant, and he writes excellent books. So if you're looking for a good book to read, Thinking in Numbers by Daniel Tammet is even better than this. And he set himself a task of learning as many digits of pi as possible. And then you might ask why, but because it's somehow, and he uses the phrase, that the whole thing possessed him. You know, the challenge possessed him. And I use the other phrase, when he tried to learn them all, the digits insinuated themselves into my mind. The digits insinuated themselves into my mind. There we are. And he has a chapter in his book about the experience of setting a European record. And what he did, he arranged to hold the meeting in 2015 in the museum in Oxford, the Oxford Museum, and on a wet Sunday afternoon, people were invited to go into the museum, and then this chap, Daniel Tammet, would sat in the middle. He had people from the Guinness Book of Records with him, and he began to recite the digits. And I'll just read, and he's got a phenomenal account of the experience of doing that. And I've got one paragraph here which I've taken from the book and included in a shortened version to get the experience of what it was like. All eyes are on me. Nobody moves. I sip a mouthful of water and hear my voice begin. 3.14, 15, 96, 53, 58, 97, 93, 23, 84. It takes about 10 minutes at a rate of 1 or 2 digits per second for me to reach 1,000 digits. I stop reciting to sip water and catch my breath. The pause seems palpable. Dolorous, even. Dolorous, which I don't use very often. Dolorous means, well, dolorous is sorrowful. Sorrowful, sort of, there's a certain sorrowfulness in the room. An hour passes, and then another. My solitude is absolute. I do not want to return the people's stares. On the cheek, here and there, I cannot help noticing tears. Perhaps the experience has taken the audience by surprise. No one has told them that they will find the number tangible, moving, yet they succumb gladly to its flow. Reciting, I try to summon up a true picture of what I see and feel. I want to convey the shapes and colours and emotions that I experience to everyone in the hall. I share my solitude with those who watch and listen to me. There is intimacy in my words. 5 hours have now elapsed. My speech begins to slur. You should be surprised. I have got drunk on exhaustion. Tension stirs me for the culminating burst, and then there is nothing more to say. I have finished recounting my solitude. It is enough. Palms come together, hands clap. Someone lets out a cheer. A new record, a new European record. 22,514 decimal places. Congratulations. I take a bow for 5 hours and 9 minutes. Eternity visited a museum in Oxford. Great, isn't it? Just the way in which he describes the whole experience, And you imagine these people dispersing and going out into the rain in Oxford and all going to the various places. And with that feeling that they haven't learned anything, but they've experienced something. So it's a remarkable thing. So I want to show you some pictures, if I may. Just to get you a sense of what other silly things people do with this pie. First of all, just to show you that plaque, that's the plaque that's on the stool in, where? Llanfairpwll. You're good learners in Llanfairpwll. And it's there only in Welsh. And it simply says, William Jones was raised and was taught in this area. And that was put up by the Anglesey County Council. Before then, there had been absolutely nothing. This is typical of a mathematical joke, where the person is doing a selfie, isn't it? It's a selfie, isn't it? It's a selfie. And it says, I don't think I can fit everyone in. Surprise, surprise. and then you have examples of what kids do on Pi Day. So that's an example of a cake with Anglesey on it and pie on it, and showing that it does some circular events. And this is another school which does a whole range of cakes. And I've actually sent this a few years ago. I thought it was something to exercise your muscles, but it's not. It's not, is it? It says you get some. What's the word I want for? Pastry. It's a pastry cutter, and this is from America. It's a pie maker, yeah. incredible. You know, and there are all kinds of things. I haven't yet mentioned my tie. This is my pi tie. And I have on it lots of digits. I'm not quite sure how many I've got. Clearly I haven't got them all. But there must be, I guess there must be 1,000 or so digits on this tie. You know? And we just show one some other pictures. There we go. So that was this pastry cutter and some round little pork pies, yeah. And people do all sorts of strange things. So, for example, look at that. On the left, you've got 3.14 pi, and then you have a mirror, and you see the reflection of that, and you see what people do with their spare time. I don't know. And then I try to finish with this, or almost finish this. But I see an hour slip by. I came across this, which is a good end to any session, which is a bottle called Pie. And this is a Sauvignon, red wine, and for some reason or other, the manufacturers decided to call it Pie. And with that, I shall conclude, I think.
Well, who'd have thought a talk about pie could be this engaging? Very, very well told story of pie, and we have some time for questions. So, who would like to ask about pie? Any questions on pie? Yeah.
Hello, I always thought that pi was actually 22/7, but you've actually educated me tonight. But what actually is it? How do they calculate? Is it dividing one number by another number?
Well, yeah, it's dividing the circle by the diameter of the circle. But of course, you never know what the circumference of the circle is, because how do you measure it? You can only measure it in theory. And the way in which they calculated for example, the area of the circle was to cut the circle up into triangles, and then you could work out the area of a triangle and add them all up. But then you've got some bits which are missing, and so you put some more triangles in there and you add those up. But essentially, you can't actually measure. You can't measure anything. For example, you ask the question, what's the thickness of a line? Well, it doesn't have a thickness. So if it doesn't have a thickness, how can you see it? And as soon as you have a thickness, you don't know what thickness is, because you can't actually measure it properly. So maths is in a sense, is a very abstract thing. Very abstract thing.
You know, when you draw a circle with a compass, that should give you a means of measuring the distance the tip of the compass, you know what I mean?
Yeah. Oh yeah, yes. And
electronically we could measure the distance travelled by that point.
Yeah. But you can never get it exact. You see, you can never get it exact to 1,000 decimal places.
Do you need that?
Absolutely. But there are some people who face the challenge of reciting, more than 22,514 digits.
So Gareth, I was just trying to think, when would you need that many digits? And do you need more digits if you're trying to decide trajectories of spacecraft?
No. You might want up to 10 digits if you've got something very, very accurate. But as soon as you're into 50 digits, it's meaningless. It is really meaningless because there are not that many atoms in the whole universe, And yet there's this sort of fascination with remembering thousands upon thousands. There's something which is an annual attraction.
That's strange.
It is strange, isn't it?
Any more questions about height? Yeah.
First of all, thank you very much for engaging us so much on what is a very conceptual idea. But I suppose my question will be, has anybody come up with why pi is an infinite number?
Yes, you can prove mathematically that it is. I won't prove it now, but you can go through a mathematical proof which shows that pi is an infinite number. That was also proved not by Euler, but somebody called Lambert, I think, a few years after that. And it's been a bit of a chase. How can you actually prove? How can you actually prove that it goes on from infinite number of digits? And it's not an easy proof.
I can believe it. But I suppose a follow-up question before Roger gets the mic. What about E?
Yeah, E is 2.619 stuff, isn't it? To do with logarithms. And E is also a rather strange number. Yeah. There is a very famous equation in mathematics which includes a number of symbols like pi and E, and it uses I'm just trying to see what else it uses. It uses minus, the symbol minus, it uses 1. 1 is a very important number. And it uses a number called I. It's the square root of minus 1. That's a tricky number. It's the square root of minus 1. But the equation is unbelievable. It's E to the power of I times pi. So you multiply this I by pi. E to the power of I pi is equal to minus 1. Good God, what's going on there? But you're into higher mathematics there.
Can I just say that E is next month? And this is pi tonight.
Yeah.
I thought it was pi tonight. Never mind. Right,
E by Tom.
Please forgive me for being so stupid, but 100 times. But the bunch of triangles thing is what fascinates me. And so a load of isosceles triangles, half the base times the height, that, so you can get that. So the base needs to be nothing, doesn't it, to get a circle?
Yeah.
But the base, if the base is very, very, very tiny, then you can work out the area of a circle as well as pi can.
No, you can use those tiny triangles to get an approximation to pi.
Yeah.
You're not getting pi.
But pi is an approximation, isn't it?
Pi is an exact number. It's just that it goes on forever.
Yeah. So it's an approximation, isn't it? Because it's never quite.
Yeah.
And the other thing that I was sort of fascinated by. Oh, am I boring?
Well, at least it didn't come out when I was talking.
It must be something I said. So the other thing, good night, ladies. The other thing that I was thinking of, that many things in nature are trying to be a circle, aren't they? I mean, we all know that the Earth, for instance, is a disk. And everything's trying to be a circle.
Yeah.
That's what a disk is. And is a perfect circle, does a perfect circle not exist? Because it's pi is an approximation, as is the triangle, the bunch of triangles.
Yeah.
So does a circle exist?
It only exists in the mind. It doesn't exist in reality.
I'm going to take it away from him.
You know, I mean,
Jesus.
but only in the sense that a line only exists in the mind, because you never get a perfect line, because it's got some thicknesses, you know. So a circle only exists in the mind. I mean, you know, if you think about this too carefully, you send yourself mad. Yeah.
Yeah.
Yes.
How is it possible to calculate it? Is it conceptual, or how is it possible to calculate it when measuring instruments and accuracy would have been less than today?
Less than today.
Yes.
Yeah, well, you have various algorithms which can calculate pi up to a certain number of digits. So you ask the question first of all, how many digits do I want to know? And then you turn the algorithm and it produces. There are all sorts of little formulas, you see, which tell you approximations for pi, and so you choose the one that you want. But it's, you know, don't worry about it.
Did you not need to have a circle?
No, that's right. That's right. I mean, for example, you could find out pi. Let me give you another formula. You could find out pi by taking 1 minus a third plus a fifth minus a seventh plus a ninth. So these are going alternately plus and minus, and they're going 3, 5, 7, 9, the odd numbers. And if you churn that out, you get a quarter of pi. And you wonder, that's a fair slice, a quarter of pi. But that's...
Thank you very much. I've got another question. It's a little bit easier.
Yeah?
You said that you saw a school child who got pi to 55 numbers.
Yeah.
And then you said the world record was something phenomenal.
22,000, no, 70,000.
What is your number?
I only know more than 6.
Okay.
3.14159. Because ultimately, what the hell?
And it's called big matter.
But it has that fascination, isn't it? You know, I was fascinated by Daniel Tennant, who did it, and the experience he had of doing it. You know. But I wouldn't want to learn all those digits.
Well, look, thank you very, very much. That was a fascinating talk, and we're very grateful to you. And the book is a tenner, and obviously there's much more in it than just the pie man. So thank you for that. And we're now just going to do this very quick. Hope you can forgive us. Just this sort of summary of the year's activity, which we need, or the purpose of the group, which we need to do for regulatory reasons.
Should we give him the clap first?
We should. I've just seen there is a pie on your sock as well.
Oh yes, I got special socks on, yeah.
Very good.
I forgot about those, yeah.
I just would like to add a small thought, or observation, I should say. We've been talking about Llanfairpwll, and we've actually encountered Llanfairpwll twice now with
Robert Rollrice, yeah.
You know, who gave us a really good talk, and Sir Owen Thomas.
Sorry?
Sir Owen Thomas was
All right.
from Llanfairpwll.
All right.
And he apparently lived in Robin Grove White's family home for some period of time.
Right.
Again, also from Llanfairpwll.
All right.
So Llanfairpwll is a bit of a special place.
Yeah, absolutely.
We remember that Sir Owen was a farmer and a soldier and a politician from Anglesey. There you go. That's brilliant. Everybody remembers, yeah. Shall I give this little... So Think Rusnaga is a community interest company, and... oh yeah, sorry.
So, and one of the things that, as Owen said, we've got to just give a report to the members. And the reason I've got my glasses on and I can't see you is because I've got to read the report. Once we've given the report, then we'll be able to say we've given a report to the members, and then we'll submit the proper thing to the regulator. So here we go. So Think Ross and Iger is a community interest company, and there are a number of hoops that need to be negotiated, and we submit the report, as I just said. So basically, the objectives of Think Ross and Iger are around enabling not just local residents, but anybody with connection to Ross and Iger to come together to discuss big questions on life, and to promote local businesses during the lean winter months. And in the words of our lovely David Griffiths, recently departed, we know that Ross and Iger is renowned for water sports such as kite surfing, windsurfing and kite foiling and golfing and sailing activities. In other words, it's brawn, but we want to make Ross and Iger famous for its brain as well. And these two activities complement each other and don't clash. And so we want to restate that, and we seek to generate discussion on big issues and all aspects of philosophical, political and scientific thought, and to bring the community together for that discussion, meeting up in a convivial social setting. As a report for this year, it's worth noting that the last year started with us treading very carefully out of the COVID, and people being quite fearful of coming together and catching stuff. And also, there's been a war going on as well, so things have been difficult. But just for the record, our financial year runs from 1st of June to 31st of May. But we decided during the year that we'd like to try and raise the profile of our operation a little bit. And we were spurred on by David meeting AC Grayling and the fact that he was prepared to come along. And it started to give us the feeling that, well, maybe we ought to try and get some big speakers along to this forum. And so, but to do that, really, we need to be able to have enough funds to be able to pay their expenses, because big speakers often command fairly big expenses. So in April, we started to collect subscriptions from our membership for either £20 per year or £3 a session. And we also started a scheme whereby we take orders for the payment of meals in advance of meetings, which has allowed us to provide stable foods, the food providers here, a better idea of the numbers that needed to be catered for, and so reducing their wastage and time queuing at the bar. And Think Ross and Iger takes £1 per meal to pay for the speaker and possible partners' meal as well. So, we collected over £900 but towards AC Grayling coming to speak to us. Whilst we have had to return some of that money to some people, most of us have left the money in the bank to cover the expenses. And when he does finally make it, obviously you will be able to come along for on that ticket. Thanks for coming. So just to finalise, we closed our year with a credit in the bank balance of £2,321, which is very healthy. But of course, £900 of that is for the people who've paid in advance for the AC Grayling talk, and we recognise that. Just to run through quickly what happened during the year. Our first talk in June 2022 was delivered by our own Reverend Vince on what is a human being. And David wanted at the time to use some Shakespeare. What piece of work is a man, or how noble in reason, how infinite in faculty. But we didn't do that. We let Reverend Vince keep going. In July, we had Prof. Chris Fletcher give us a talk on the passage of time, recognising and understanding events in Rosniger Rocks. And then, while we took previously taken a break in over the summer, because we were really focused on the winter months, this last year we actually kept going over the summer, so that we could actually show people who just came maybe on their holidays, you know, what a thriving centre Rosniger is. And so we have kept going through the summer there. Just going forwards, but in October we, in preparation for the AC grading visit, we wanted to test whether we could use a bigger capacity forum, and so we tried Rosniger Village Hall out with a talk that was given by Derek Brown on consciousness, and this allowed us to test the idea of using other local food outlets after the talk. We had some bad news in November or late October that Prof Grayling wasn't able to come because of the train strikes, which would make it impossible journey from Oxford up to Rosniger. But we've had some good news, because Barbara has managed to have a chat with him at the latest National Rejoin March on the 23rd, and AC Grayling has reconfirmed his commitment to come to give us a talk, which is brilliant. On the 15th of December, we had Dr. John Lewis give us a talk entitled "Is Death to be Feared?", which was very enlightening, and it sort of considered the idea of DNR, do not resuscitate notices, which was discussed a lot. In December was when David died, and we really miss him, and we're proud to be able to keep this going in his memory. So I hope everybody feels that's what we're doing, and it is doing a good thing. In January we had Sean King to give us a talk on can capitalism be responsible. Sean's a merchant banker of many years' experience, and his central theme was based around implications of ESG in corporations and governments, and that was a highly animated discussion. In February we had Philip Wheeler give us a talk on talk is cheap but is speech free. And amongst Philip's claims to fame is that he acted as a legal advisor to the BBC's famous "Have I Got News for You?" And based on this experience, advises many household names, corporations, and how to avoid being sued. And in March we had Gareth Llewellyn, who was the former chief executive of Mentamon, and talked to us about the objectives of Mentamorlays, with the title "Can Anglesey Lead the World in Tidal Stream Technology?" So he gave us a great talk on the fantastic new tidal turbine electricity generating facility that's being tested off the coast of Holyhead, and of course that talk generated great discussion, pros and cons of different green technologies. And in April we had a fantastic talk by Robin Grove White, and excuse me, over this page there.
who's Robin Grove-White, who's Professor of Environment and Society at Lancaster University and former chair of Greenpeace, and talk about getting real about climate change, which was another fantastic talk. In May, we had Aled Morris Jones give us a talk on Sir Owen Thomas, who Bobby referred to, the other guy from and he was a true statesman and farmer, soldier, and politician. Finally, then in June, we had Will Rendell, who's a PhD student, gave us a frightening insight into the current trends in human population growth and the fact that human population might drop off the end of a cliff very soon after the turn of the century due to changes in fertility. That's getting ahead because, of course, we're now into next year. So we'll do a report on that going forward. So that's our report, and I don't know whether anybody's got any questions or whether everybody's happy.
Yep, so if there are any questions about that, do raise your hand. And the last thing to say is that if anyone has ideas for speakers, I think we've got 5 months worked out going forward, which we will post. And we've got quite a few after that as well, all sort of either lining up or halfway there or whatever. And so we're almost a year ahead. But if people have ideas, please do just email Mark, whose emails you should get about the food and all the tickets and all that. So that's it. Thank you very much, Professor Roberts. Very, very excellent talk, and we're very grateful to you. Thank you very much. And hopefully you'll join us for a meal. You're very welcome to join us.
So food should be ready about 8 o'clock.